I think in this talk, I decided I was going to have you come away with three things. So there's three things I want you to remember. First is about this slide. So I think Yuri Levine was on Lenny's podcast. Did any of you know Lenny's podcast? Excellent product podcast. Yuri said that this slide, your intro slide, gets the most airtime out of any slide that you have. And it is the least useful slide that you use in your slide deck. It is a template slide that usually says company name. So put something in there that is meaningful to people because this slide sits in front of them for the longest amount of time. That's the first thing I want you to remember. I'm Bryan Clark. I'm the VP of Product at Neon. I've been at Neon for about 2 months. It has been a whirlwind. I came from a company called Timescale before. Before Timescale, I was at GitHub for 4 years through the acquisition by Microsoft. And I'm going to talk to you today about two other things. The next one is whenever you give a talk, and I had a public speaking coach tell me this, within the first 1 minute, you want to tell a personal story, something that will bring people to remember your talk, engage, and not look at their phone. This is my personal story. This is the second thing I want you to take away. I have a hobby project, and I think all of you probably have a hobby project if you're a developer here. My hobby project is, I do this integration with Strava to get like the API data from them. I put it into Slack. It's this like thing that I've been working on for quite a while. I had some time over the weekend and I wanted to work on this hobby project. I wanted to, like, you know that feature where you're like, oh, I want to build this one feature. That's what I'm going to do with this like 2 hours of my time. I have three kids, so I do not have a lot of time. So having 2 hours to sit down and focus, that was really beautiful to me. And when I implemented this feature, the final step in my implementation was a merge to production. And I hit this message. I don't know if you know what this message is. If you've used Prisma, you've probably seen this message before. So this was the, like, I closed my pull request, I pushed the code out to production, and I hit this. It is not something like this. If you're thinking, what is drift detection? That would have been very useful in this GIF. Drift detection, or drift detected, is actually your database being out of sync. So I'll tell you a little bit about why this happened. And because this is my personal project, this is exactly why my database got out of sync. The next thing that Prisma asks is, do you want to basically reset the data? In the deploy thing, it doesn't try to do this. This is what really happens in dev. I'm maybe embellishing just a little bit here. But also, like, the natural thing is your database is out of sync, and Prisma is trying to help you get up to speed with that. What I did is a long time ago, maybe a month ago, I ran an index advisor, one of those things that like examines your Postgres, tries to tell you indexes you should use. I really wanted to improve the performance of my side project, and I wanted to try out these things. I think it was like PG Analyze or something similar like that. So I used this index advisor, and they give you a Postgres create index for X. So I took that code, I ran it in the production instance. It did improve the performance, but I didn't have that indexed in my developer ecosystem. Like, I didn't have that thing stored in code. So now, as I developed all this code and I pushed up this pull request, and I merged, and I'm about to go live with production, and I'm really running out of time that I have for this like pet project of mine in order to get things going, this index is causing me a problem. If you go to, if you search Prisma docs, they actually call out this exact thing in the documentation. This is what they say to do. Like, the next step in your process here is that you have an index in production that doesn't exist in your code, so you run this Prisma migrate in order to retroactively create the index. You have to like match the name because the index advisor had named the index, something that I would normally do, or maybe Prisma wouldn't normally name it. So I have to do this step. That's a little painful. The next step is that then you have to try and get this out to production, because now like my PR is waiting. I really want to get done for my weekend, but I'm kind of messing with production code. I'm really getting nervous about the state of my system, and it's just essentially not what I wanted to do, right? Like after I got that migration done, I was not happy with the state of how things worked. And this is kind of one of the problems I came to Neon to help solve. So preview environments are an excellent thing. Like, development has changed so much by having Git, pull requests, branching, preview environments to see things and change them and understand what they look like. But in a lot of ways, databases have not kept up. Databases, Postgres in particular, was designed a decade ago. It was not designed for the kind of high-speed workflow that you use right now. And so that creates what is generally a pattern that I think is the wrong pattern for developers to use. And that's what I did. So typical data DX pattern here, you start with an empty database. So in your pull request, you generally have like an action or some kind of like pipeline. You'll ask for a Postgres database. That one is an empty database. Then you run like Prisma migrate dev. That creates your first schema. So now you have an empty set. Now you need some staging, like seeding data in there, so that you can play around with your previews. But already, right now, what you've done is you've taken the code that describes your schema, you've pushed it into your pull request and that environment, and it's totally different than production. So the next step, what I did here is that like I tried to merge to production, it wouldn't let me. And that was the right decision for Prisma to kind of pause and say like, this should be part of your code, but actually databases should be fixed. This is how you branch from main to development, right? You take whatever Git has as main and you pull that as a branch, but in database world, you don't do this. So the third thing I want you to remember is don't wait for the merge to production to like tackle these changes. If you do what I did, like you enter this state where now you really have to fix production, you have to fix your staging environment, you have to like manage these changes throughout everything else. What you want to do is shift left. You want to bring that problem closer to development, you want to bring it closer to your pull requests. And so what I'm talking about here is, and Neon does this, right? Neon is the company I work for. We're a serverless Postgres environment. We do branching as part of our core offering. Our databases start up in under 500 milliseconds. So we don't slow down your CI/CD process whatsoever. And in our system, and what I've moved to now, is you branch from production. So you take your production database, you branch that in your CI/CD pattern. So whatever system, whatever full stack service you're having for your preview environment, that now uses a copy of production. You can write to that. Our file system is a copy on write file system, so you actually don't even pay for the additional data. It's really nice that like the production data is there. If you know a copy on write file system, there's actually not a copy involved. Branch, you're still pointing to the same file system, but it's all read-only now. As soon as you make a change, we create a new file in order to like manage that change. So if you start from a production snapshot or a branch, whatever your service provider offers, then you run Prisma migrate dev. In that instance now, what you're going to see is Prisma, or whatever ORM you're using, is going to complain that things have drifted. And this is the spot you want to be. This is where now, in a pull request environment, you're able to make changes. What you would do is declare that index, rename it, update your commits, push to the next version, and then finally, you can do the resolve in that same pull request. Right? And so that's going to get you to the state where you want to be. Your preview environment works, and now your final step, where you're actually going to merge to production, doesn't have that same option. No longer do you actually have to like have a mismatched state with production between your preview environment. Everything should just merge cleanly and easily, and that's because you took that issue of having the production environment, which had drifted, and you pulled it into the pull request. So that's the third thing I want you to take away from this. I'm sitting down here in a chair because they said I could do a little bit of Q&A. And what I wanted to ask is like, why aren't you branching from production now? Like, what is holding people back from integrating a database environment that actually uses this kind of system? So I think that is my next question. Hi. Does anybody have a question about branching? Yeah.
We said like, Johnny, but I've done some. I haven't.
So you say a snapshot from the production when you say snapshotting, do you actually take all the data that exists in the production? Because if you do, as a developer, that would be very scary for me to open my pull request, go to preview, see production data. I'm like, this is really familiar looking. But like, if I delete something now, what will happen? Like,
Oh, interesting. Okay, so two things. So yeah, in a branching model, your branching database should have a totally separate file system storage. So yeah, Neon's, yeah, right, it's copy on write. So if you switch to that branch, you wrote or deleted the entire thing, that doesn't affect your production database at all. That's one. So that this should be made very clear in the UI so the developer understands, and that's how that works. Two, there's definitely an item there sometimes where you have data in production that you're like, I don't want that in my preview environment. And that, I think, is actually like, that needs to be the next step in this kind of branching environment. Neon is working on this in particular. There needs to be a way to templatize and anonymize. So we've been looking at using PG Anonymize, which is a pretty good Postgres anonymization tool, as an extension that you can add to Postgres. And with that, if you labeled, let's say, the columns that you have, where you're like, this is a first name, this is a social insurance number, here's a birth date, I'm going to label those as PII, and then when we do the branching, you run PG Anonymize, and all of a sudden you're getting a preview environment that now has production data, but not the data that you're worried about. As well, I think there's a lot of cases where a customer will say, like, I have 1 terabyte of data, and that's just way too much for like a preview environment. And so I think you also need a second step where you can, before you anonymize, you say, like, let me cut down the amount of data. And this is where Postgres foreign keys work really well, because you can actually say, here is the information I want to keep, and then I'm going to delete cascade all, like everything else. And so you just drop a ton of extra data of all the stuff that you don't want. And this is inverting the way people normally do it. Like with seeding, you might run now like a seeding command where you're like, I could fill in the data that like is missing, or if I had some data that I couldn't anonymize. But usually what people do is to kind of like fill a bunch of fake data. And when you create all that fake data, you kind of create fake problems for yourself in the preview environment. And yeah, you drift so much from what's happening in production that no longer do you like, you have like the same development experience.
so speaking of like data DX, actually the like anonymizing data sounds very good from a like engineering point of view. And then the ability to control how much you use capture. Because oftentimes when you're doing the full stack features, like you actually need a lot of data, but sometimes you don't. And generating thousands or 10,000s of dummy data, it's just bothersome. And yeah, those two things actually would be very, very useful.
Yeah, usually the subset of data is key just to make things fast, because I think we did timing at Neon, and PG Anonymizer running on like a 1 terabyte disk would take 20 minutes or so to resolve, right? And that's just way too long. But if you start, especially if you have foreign keys, something to help you like start from kind of your top object. So in your database, you usually have a schema that's like users or something like that, and then users own issues or other things within the database schema. Yeah, you say like, I want to keep these users, and then I want to delete everything else and to cascade all. And then you'll end up with a much smaller data set. You can run anonymize on that very quickly. And then you end up with like a pristine and like very close to production matching system. And this is also super useful if you're ever doing like hot fixes, right? If you have something where something's gone wrong in production, you actually really want the closest version of that. If you take like a seed database or like a seeding system, in the original slides I had a screenshot of like a seed file because like whenever I see them, like the seeding files start out really nicely in the very beginning, where you're like, oh, user has issues and issues have comments, but then like as you grow in a production environment, these things become massive. And they take a long time to actually seed the database. Like you create the schema, and then you run this giant seeding program that pulls in a ton of data, and people, like developers, spend time trying to create that. Whenever they make a schema change, they now have to update the seeding system in order to also do that. It creates a whole lot more headache, whereas if you're actually just trying to focus on, all right, what if I just identify the PII and other data that I wouldn't want in a development environment, and like limit the amount of production data that comes in there, you're actually now going to get a much closer to production code system and like reduce that time spent.
Thank you.